What if the reason we've been stuck on energy for a century is not a lack of resources, but a wrong assumption about what a field actually is? In this series, I'm going to show you a device and a theory that I believe suggests we've been missing something fundamental, something hiding in plain sight. But before we get to any of that, let me tell you how this all started. The idea that wouldn't die. About 25 years ago, a very strange idea popped into my head. I was fresh out of the army and I was planning to become a software developer. I had zero education in electricity, zero background in physics. I mean, genuinely nothing. And yet this idea appeared, a device that generates electricity. No combustion engine, no fuel, no external energy source, just electricity out of what most people would call nothing. Now the rational response when you have no credentials, no education, and no money is obviously, forget it. And that's exactly what I did. I buried it. I grew up in a society where rules are followed and questions are not asked. Schools teach you what to think, not how to think. Failing isn't a learning experience, it's a verdict. That kind of environment doesn't produce pioneers. It produces very efficient, very obedient worker bees, and for a long time I was one of them. Years went by, I got married, had kids, kept working, doing exactly what you're supposed to do, following the path everyone lays out for you. But there's a particular kind of exhaustion that comes from swimming upstream against your own nature, and I didn't even recognize that's what I was doing. The further I drifted from what I actually cared about, the heavier everything became. Depression didn't arrive overnight, it crept in gradually, the way it does when you spend years ignoring what you're really meant to be doing. The marriage didn't survive it either. Through all of it, I kept searching for answers in physics books, as if theories about the external world could somehow resolve the turmoil in the internal one. And the whole time, a quiet voice in the back of my head kept saying, "You're not capable of this anyway, so why bother trying?" Then I met someone who changed everything. She helped me see that every single limitation I believed about myself had been placed there by someone else, and I had simply never questioned whether to keep them. It took about 20 years from the original vision to reach that moment, but once I did, I stopped waiting for permission. I started building the device, and to explain the device, I had to build the theory. Why this is hard to explain, and why I'm going to try anyway. Fair warning, this is not going to be a linear journey. The theory and the device are so intertwined that I'll need to jump back and forth, explain a piece of the theory, show what it means for the device, go deeper into the theory, come back to the device. Think of it less like a lecture and more like assembling a puzzle where every piece makes more sense once you have a few others in place. I'm keeping the math out of the video, not because it doesn't exist. The actual toroidal torsion field theory is 13 papers, more than 500 pages long, and on top of that I have published several editions with full derivations, all publicly available, but because throwing equations at you won't help you understand. Understanding comes from intuition first. Math is just the receipt you print afterward. Toroidal torsion field theory, the basics. My theory is called toroidal torsion field theory, TTFT for short. It is not a completely new idea. Tesla, Maxwell, Heaviside, Steinmetz, J.J. Thomson, Walter Russell, Lord Kelvin, some of the greatest minds in the history of physics were circling something similar. They never had the tools to take it all the way. TTFT stands on their shoulders. To understand where TTFT differs from modern physics, let me use Einstein's general relativity as the reference point, because GR is the gold standard of current mainstream theory. Here are the three most important differences. First, GR takes geometry as an input and derives motion from it. TTFT does the opposite. It takes motion as the input and lets geometry emerge from that. This is not a small distinction. It's a complete reversal of the foundational logic. Second, GR treats spacetime as the stage, the fundamental arena where everything happens. TTFT says spacetime is not the stage, it's a byproduct, something that emerges. There is no pre-existing spacetime in TTFT. Third, and this one is personal for me, GR, like the entire standard model, requires free parameters, numbers you just have to measure and plug in. The gravitational constant G, the fine structure constant, the electron mass, the speed of light. These are treated as fundamental, meaning we don't know where they come from, so we'll just call them fundamental and move on. TTFT derives all of them from geometry without plugging anything in. Newton measured gravitation constant G, then Einstein settled just to use the G, but TTFT derives the G, and I'll show you how later. Richard Feynman once called the fine structure constant, the number that governs how light and matter interact, one of the greatest damn mysteries of physics. A magic number that arrives with no explanation. TTFT explains it, derives and predicts it with high precision. I'll get to that too. What does first principles actually mean, and why should you care? You've probably heard scientists use the phrase first principles like it's a badge of honor, but what does it actually mean? A first principles theory is one that derives everything from a small set of foundational assumptions, with no free parameters, no tuning. No, we measured this and plugged it in. Think of it like the difference between a map drawn from actual surveying versus a map drawn by guessing and then adjusting it until it fits. Both maps might look similar from a distance, but only one of them actually tells you something true about the territory. General relativity is a magnificent theory, genuinely one of the greatest intellectual achievements in human history. But it is not a first principles theory. It assumes spacetime. It assumes the equivalence principle. It uses Newton's gravitational constant g as an input, meaning you have to measure g with an experiment before general relativity can make a single quantitative prediction about gravity. The Standard Model, our best theory to explain physical particles, is even more exposed. It has 19 free parameters. 19 numbers that the theory simply cannot explain: particle masses, coupling strengths, mixing angles. All of them have to be measured in a laboratory and inserted by hand. The Standard Model then agrees with experiments beautifully, but it never tells you why those numbers are what they are. When you ask, but where does the electron mass come from? The Standard Model's honest answer is, we don't know, it just does. TTFT starts from 5 geometric postulates: spatial topology, torsion as the primary field, flux conservation, compactness and gauge symmetry, and derives everything else. The gravitational constant g emerges from the torsion spectrum. The fine structure constant, Feynman's greatest damn mystery, emerges from the normalization of the genus 1 TTFT's U1 equivalent torsion mode. The electron mass emerges as the lowest stable torsion eigenvalue. The golden ratio emerges from the renormalization group flow of the geometry itself. Not one of these is plugged in. Every single one falls out. That is what first principles means, and that is the difference between a theory that describes nature and a theory that explains it. The mysteries mainstream physics couldn't solve, and what TTFT does with them. Mainstream physics has an awkward list of open problems it has been carrying around for decades, problems that are serious enough that the best minds in the world have spent careers on them, and embarrassing enough that most textbooks don't quite admit how stuck everyone is. Why do particles have the masses they have? The Standard Model has no answer. It measures them and moves on. TTFT predicts the entire fermion mass hierarchy, all 12 fermion masses from a single geometric scale, and the golden ratio spectral recursion of the torsion operator. 10 of 12 masses land within 1 to 10% of experiment, with no fitting. Why is there a matter-antimatter asymmetry? Why did the universe end up filled with matter rather than annihilating itself at the beginning? This is one of the deepest unsolved problems in cosmology. In TTFT, the helical torsion condensate on the 3 torus has a preferred handedness. Parity violation is not inserted, it is geometrically forced, which provides a natural asymmetry mechanism without requiring new physics beyond the geometric framework itself. What is dark energy? The Standard Model of cosmology assigns roughly 68% of the universe's energy budget to something it cannot identify, characterizes it with a parameter called W, and then admits it doesn't know what W is. TTFT predicts W equals -1.026 plus or -0.006 directly from the torsion curvature condensate, a slight phantom-like deviation from the cosmological constant, arising purely from the golden ratio equilibrium structure, with no ghost instabilities and no new fields introduced. Upcoming surveys from Euclid and Dacey will test this at the precision required to confirm or falsify it within this decade. What is the muon G2 anomaly? For years, measurements of the muon's magnetic moment have disagreed with the Standard Model prediction at a level that physicists find deeply uncomfortable, a persistent hint that something is missing. TTFT predicts the muon anomalous magnetic moment directly from the overlap integral of the genus 2 torsion modes, arriving at a value in remarkable agreement with the Fermilab experimental world average, with no fitting parameters. Why does gravity not unify with the other forces? In the standard model, gravity is simply left out. It cannot be quantized using the same methods as the other forces, and nobody has bridged the gap despite 70 years of effort. In TTFT, there is no gap to bridge because gravity is not a separate force. It is an ether pressure deficit around any mass configuration, and it emerges from the same geometric framework as electromagnetism and the nuclear forces. This is the brief backstory and short explanation of the differences between TTFT and mainstream theories. On next episode, I will introduce the basics of the TTFT and the device itself.